Today's problem is replace O's with X's. You are difficulty, medium. You are given a grid of size n by m where every element is either O or X. You have to replace all O's or a group of O with X's that are surrounded by X's. That isn't a very good explanation. An O, or a set of O's, is considered to be surrounded by X if there are X's at locations just below, just above, just left, and just right of it. Okay. I really don't like that explanation. But let's take a look at this. The key here is O or a set of O. Okay? Now none of these O's is surrounded by X's, up, down, left, and right. But there is a set of O's, then that would be this sort of sideways T shape. I can't do that, but sideways T shape here in the second column and then extending into the third column. That whole set is surrounded by X's. So those wind up being changed to X's in the output. And these lower two here, there's no way to surround those by X's. All right, the examples in this case are pretty good. They're a good tip-off of what we want to do. This one, there is no O that's surrounded by X, okay? So nothing changes. The reason there's no O that's surrounded by X is the border rows and the border columns, okay? Any O in a border row or column is not going to be surrounded by X's because you're out of space here. I mean, this O here, for example, there is no cell on top of it, and it is never going to be surrounded by X's, and that is true of any O that is connected to this O. So we can take these border O's and do a breadth first search on them, and we'll find that all of them can be connected to a border O, therefore none of them change. Okay, now it's different over here, because while these O's here are on a border row and we can't change them, these O's, and as we're doing this, we mark all of these as visited, okay? Now, by the time we do this second example, every cell is marked as visited. This one, if we just do searches from border rows, these two in the lower right will be marked as visited, but the ones in the middle are not. And so all of those can be changed to X's. Because if they're not on the border and they're not connected to anything on the border, then you're going to hit an X. Doesn't matter which O you pick or which direction you go. You pick, this one. If you go up, you hit an X. You go right, you hit an X. You go left, you hit an X. You go down, eventually you hit an X. There's no way to connect those to a border, and so they are surrounded. All right, well, I forgot to look at the constraints here. Grid size between 1 and 100 inclusive. That would be the number of rows. Grid 0 size. Grid at 0 size also between 1 and 100 inclusive, so there can be up to 100 columns. Expected complexities, n times m. Yeah, that's right. We are going to hit each cell once, auxiliary space. We need a Q for the depth first search. So that's the, well, that's the auxiliary space. And actually, we also need a visited array, same dimension as the original array. Topic tags, recursion, matrix, graph, breadth first search. All right. Let's take a look at what we're going to do here. We've got some class variables, rows, columns, the visited array, the queue. You don't have to do it that way. It just depends on how much you enjoy passing a lot of variables between functions. And so in general, I prefer to set them as class variables, but okay. Fill, this is the main method here. We're going to get the number of rows. We're going to get the number of columns. We're going to create our visited array to Boolean, the same size as the input array, and Java will initialize a Boolean array to false. Okay, we're going to set up a queue. Process border columns. Okay, so if you've thought this through, ahead of time, which you should, and you have a good idea of the approach that you want to take, it's a good idea if you can see that there's going to be a lot of code to break the code into methods. And what you can do, the first time through, you can say, well, I know I want to process the border columns and see if there's any O's in there. And I want to process the border rows and see if there's any O's in there. Those would go in the queue, and then I can do my breadth first search. All right, and then you can fill in the details of these methods later. Okay, processing the border columns. So first of all, we're going to fix I at 0. This is, okay, wait, let me make sure I get this right. Yeah, so this is the first column. So we're going to fix I at, I'm sorry. We're going to run a loop of I from 0 to the number of rows. Okay, we are going to fix j at 0. So we're going to we'll process 0, 0, 1, 0, 2, 0, whatever, all the way down the first column. And if that cell equals an O, we add it to the queue for breadth first search, and we mark it as visited. Same thing with the last column, but we fix j at columns minus 1, which in our example, what was columns? Columns minus 1 is going to be 3. Okay, so we will do 0, 3, 1, 3, 2, 3, 4, 3, 5, 3. If the cell is an O, again, add it to the queue for the breadth first search and mark it as visited. The next step was processing the border rows, really the same thing. In this one, we are going to run j from 0 to the number of columns, and to process the first row, we're going to fix the I coordinate or I index at 0. So we'll process 0, 0, 1, 0, 0, 0, 1, 0, 2, etc. If we find a 0, put that set of indices in the queue, mark the cell as visited. We do the last row. In this case, we're going to set the I index at rows minus 1. Rows minus 1. Columns minus 1. You know what? I think I said columns minus 1. Yeah, rows minus 1 is 4. So we can go up to 4. No. Rows minus 3. 3, 3, 0, 3, 1, 3, 2, 3, etc. If anything is an O in the last row, put it in the queue, mark it as visited. Breadth first search, it looks like pretty much every other breadth first search. We have the directional arrays to create the indices for the neighboring cells. While the queue is not empty, take it off. Get the row number, get the column number. Look at all the neighboring cells. If it is valid, and I put that in a separate method, valid just means we're going to take the row and column that we generated and make sure that they are within the bounds of the array and that the cell has not been visited. Okay, so if it's valid, if the cell is an O, the reason we're looking at it is because it is connected to a border cell. Okay, that's the only thing we can put in the queue is the border cells. So if this breadth first search hits an O, that O is connected to a border cell, and it is not going to be surrounded by an X. We just mark it as true, as visited, and add it to the queue to complete the breadth first search. All right, when the breadth first search finishes here, what we're going to have is possibly, well, yeah, we're going to have 0 or more cells that are O's and have never been visited because they're not connected to a border cell. That's this. Loop through the matrix. If a cell has not been, if an O cell has not been visited, it's surrounded by X's, and we can change it to an X, and that's it. There's nothing to return because the grid gets updated in place. So, having said that, let's try and run it. Okay. Yeah. So the key insight there really is that any O on a border is never going to be surrounded by X's, and any O connected to an O on a border is never going to be surrounded by X's. However, all of the O's that are not connected to to O's on a border, those will always be surrounded by X's. So just take the O's on the border, do a depth first search to find all of the connected O's. Whatever's left over is going to be changed to an X. Please go ahead and like the video. You can subscribe to the channel. And that's it. We'll see you next time.